Hello, I'm Maddie Camp, a senior at Rice University studying civil and environmental engineering. My JISAO summer internship was with the Alexander Group in the Department of Atmospheric Science. To help explain the motivation for my work this summer, I have created the following dramatization. Please note that no such conversation actually occurred and that I have worked exclusively with inanimate samples.
So let me get this straight. You say you were in the remote marine boundary layer. And all of a sudden you're not sulfur dioxide anymore. No, you're not even a gas anymore. You're telling me you've been oxidized to particulate sulfate, and now you affect climate by changing radiative forcing through direct scattering and changing the properties of clouds, like their lifetime and their brightness. Now, your main oxidants are normally hydrogen peroxide and the hydroxyl radical. However, some modeling studies are suggesting that up to 30% of your oxidation could be done by hypohalous acids. And you want to know who done it, huh? You're asking a serious question. Give me one reason why I should help you. I'll give you 10 weeks, and I'm going to need your oxygen isotopes.
And so began my summer internship, analyzing the oxidants of sulfate by looking at the relative amounts of oxygen 16, 17, and 18 present in samples collected in the remote marine boundary layer. The ratio of these isotopes are sort of like chemical fingerprints left by the oxidants. Different reactions result in a different ratio, so by looking at the ratio that we calculate, we can determine what chemical reactions have happened. My work was broken up into 3 different parts. Sample preparation in the Alexander lab, where we dissolved the samples and isolated the sulfate with ion chromatography. Sample analysis in the UW-ISO lab, where I used an isotope ratio mass spectrometer to separate out the oxygen isotopes from the sulfate sample. And finally, I worked with a box model to investigate feedbacks between sulfate and hypohalous acids. The project will continue until all samples are analyzed, and an improved sulfate oxidant inventory will be put into a global chemical transport model so that we can better predict the effects of sulfate on clouds and climate. Thank you to Becky, Jen, Lei, Maria, and Lauren in the Alexander Group, and to JISAO for a great summer experience.
Featuring Resin, sample 2011 NJQF07.